So our first option when trying to evaluate the limit of functions is we'd like to solve by substitution. It tends to be the cleanest way to go. When it's possible, this is the route we want. Let's start with the simplest of all functions, just a horizontal line. The limit as x approaches 5, 2. The limit of a constant is just the constant. So in this case it's 2. Think about this graphically. If we were to graph this function, there would be a horizontal line going through 2. And what we're saying is that as x gets arbitrarily close to 5 from the left and from the right, the outputs are getting closer and closer to 2, or approaching 2, and this is true. Now, a different limit problem would be something like the limit as x approaches 5 of x squared minus 10x minus 25 all over x squared minus 4x minus 5. Now if we were to substitute into here, in the numerator, we're going to get 25 minus 50 minus another 25, which is negative 50. And in the denominator, we get 25 minus 20 minus 5, which is 0. This doesn't really tell us anything. But these will factor. The limit as x approaches 5 of x minus 5 squared over x minus 5 times x plus 1. Now notice that I haven't taken the limit yet. I've just simplified the rational function, so I'm still declaring I intend to take the limit. One of those x minus 5s cancels out, and I'm left with x minus 5 over x plus 1. By substitution, I end up with 0 over 6, which is just 0. As that function gets closer and closer to 5, the outputs are going to get closer and closer to 0. So you can generally solve by substitution, or when you can solve by substitution, it's a nice way to go. Some functions, if you simplify them in some way, this could be by multiplying by conjugates, this could be by factoring, this could just be by creatively rearranging the terms in some way, shape, or form. You can still solve by substitution. This is the route we'd like to go when possible.